guys, welcome to the 4.1 arithmetic sequence video. I'm trying something new with putting my face in the corner. So it's kind of like me teaching you the lesson instead of just listening to my voice. So let's see how it goes. So first is talking about arithmetic sequences. So the definition of an arithmetic sequence is a sequence in which the difference between any two consecutive terms is constant. So you want to write the word constant on that line. And what that means is it's the same distance between every single point. So if you're adding 2 to get to the next number, then you're going to add 2 again to get to the number after that. So that's what constant means. And then the common difference is the numerical difference d. So you're going to want to circle this letter. So d is what we're going to use in the formula to talk about the common difference between any two consecutive terms. In other words, what that means is how far apart one number is away from the other. So when you're thinking of like a set pattern, you probably did it in elementary school where they gave you like 2, 4, 6, 8, and then they asked you to find the next two numbers and you wrote down 10 and 12. So you did that without even realizing you were doing arithmetic sequences. It's just the common difference was a positive 2, where you're adding 2 every time to get to the next number. And it was just, you're counting by 2s. So that's what common difference is just how much you're counting by. So determine if the sequence is an arithmetic sequence, and if yes, identify the common difference. So what I like to do is kind of spread out the numbers so that you can see what the difference is. So going from 1 to 5 to 9 to 13. So from 1 to 5, that's adding 4. From 5 to 9, that's adding 4 again. And from 9 to 13, that's adding 4 again. So this is consistent. That's a constant adding 4 every time. So it's yes, it is an arithmetic sequence, and then your common difference would equal a positive 4. Then let's change our color. We'll go to 1, 3, 5, and 8. Again, do the same thing. So 1 to 3 is a difference of adding 2. 3 to 5 is a difference of adding 2 again. However, 5 to 8 is a difference of adding 3. So because this is not constant, that 3 right there is not what it should be, then the answer would be no, it's not an arithmetic sequence. So not an arithmetic sequence. I spelled arithmetic wrong. Yep. Arithmetic sequence. All right, so the next one, 8, 6, 4, and 2. So I'm going to spread that out again. So between 8 and 6, that's a difference of minus 2. 6 to 4, again, that's minus 2. And then 4 down to 2, we're subtracting 2 to get to that. So then the answer is yes, and then D for your common difference would equal negative 2. All right, and then I need to erase to be able to move down to the next thing. So pause this if you, like 10 seconds ago, if you were not done copying. So that's the easy part, just developing the pattern and finding the common difference. And then if you're given an actual sequence, they want you to find the next 3 terms for this one. So again, you're just identifying your common difference. So on the side here, I'm going to write like D equals for each one. Uh-oh, I lost my face. There's my face. Oh, lost my face. Okay, my face. All right, so on this side, I'm just going to write D equals for each one so that I know what the common difference is for each of the patterns. So we have 9 to 13, that's adding 4. So we're adding 4 to this. 13 to 17, again, is adding 4. 17 to 21, again, is adding 4. So if I add 4 to 21, I'm going to get 25. 25 to plus 4 is 29. And then 29 plus 4 would get me to 33. So our common difference for the first one is a positive 4. Then this one goes from 5 down to 2, so that's subtracting 3. 2 down to negative 1, again subtracting 3. Negative 1 to negative 4, again is subtracting 3. So negative 4 minus 3 would be negative 7. Negative 7 minus 3 would be negative 10. Negative 10 minus 3 would be negative 13. And then our common difference would be negative 3. Then down here, we've got negative 8 up to negative 2, so that's adding 6. Negative 2 to 4 is adding 6, and 4 to 10 is adding 6. So 10 plus 6 is 16. 16 plus 6 is 22. And 22 plus 6 is 28. So our common difference would be a positive 6. And then arithmetic sequence formula, there is a formula that you're going to use, and then I'm going to tell you how to identify which letter is which. So let me change my color here. So the formula is A subset n equals D parentheses n minus 1 plus A subset 1. So A subset n, all that means is what term you're trying to get to. So if they give you a sequence, like for example, if they give you this sequence and they say, like this is the first term, this is the second term in the sequence, this is the third term in the sequence, and this is the fourth term in the sequence. But what if they ask you to find the 65th number in that sequence? Well, you could sit there and do the sequence up till the 65th time, but that's time consuming. So that's why math has formulas, because it's a lot easier if you are using the formula. So D stands for the common difference. We already know that. And you just find that by subtracting the, seeing what the difference is between the next term to the next term. But then A to the 1 is the first term, A subset 1 is the first term in the sequence. So for this one, the first term in the sequence would be negative 8. So we would, wherever A1 is, we would write negative 8. And this one it would be 5, and then this one would be 9. And then the D for the common difference would be our plus 6 for this one, or our minus 3 for this one, or our plus 4 for this one. And then A to the nth is just what term you're looking for. So if you're looking for the 65th term, then you would put 65th term here. And then n minus 1 is the 65 is the term you're looking for, minus 1. So you put your common difference, you put 65 minus 1, and then you would write the first term or whatever the first one is. And you would just solve it, and it would tell you what number it would be. So let's take a look at what it looks like in a problem. Let me erase this up here so I can move down. There's no easy way to erase this, sorry. All right, here we go. So write the rule for the nth term, then find A to the 19th term. So do you see how they give you what the n term is? So they're asking for the 19th number for each one. So the rule would be what the common difference is. So 7 to 13, 13 to 19, and the 19 to 25 would be the common difference of adding 6 every time. So the rule is adding 6. And then remember our formula is A to the nth, and we're trying to find A to the 19th term. And then the common difference would be D times n minus 1 plus your A to the first term, or A subset 1. So we're replacing D with our common difference, which is 6. Our nth term we're trying to find is 19. Minus 1 is in the formula, plus the first term in the series, so that's a 7. And that will give us our 19th term that we're looking for. So 6 times 19, well, 6 times 10 is 60, and 6 times 9 is 54, and 54 plus 60 is 114. And then 6 times negative 1 is negative 6, and then bring down our plus 7. So 114 minus 6 is 108, plus 7 would be 115. Got somebody messaging me on my remind. All right, so then your 19th term for this sequence would be 115. That would be the number. And I challenge you to try to do the formula, like one of your friends do the formula, and the other person do like actually sitting out and adding 6 every time till you get to the 19th term, and you'll beat them every time, unless it's like to the 10th term, and then, maybe it'll be the other person. But when you have a higher number that you're trying to get to, the formula is the easier way to go. All right, so now over here we've got 30 down to 26, down to 22, down to 18. So that is subtracting 4 each time. So that's the rule. And then we're going to find it to the 19th term again, but now we're using this sequence instead of those numbers over there. So the common difference would be our negative 4 for D. The term we're looking for is 19 minus the 1, And then our first term in this series is 30. So then you have negative 4 times 19. Negative 4 times 10 is negative 40. Negative 4 times 9 is negative 36. So 40 and 36 is 76. So that's negative 76. And then negative 4 times negative 1 is a positive 4. And then bring down our 30. So negative 76 plus 4 is negative 72. Plus 30 more would be negative 42. So a to the 19th power would equal negative 42. And that makes sense because we're decreasing each time. So eventually you're going to get below 0. And in this situation, it would be negative 42 would be your answer. So I hope that helped you in 4.1's guided notes. Go Seahawks. Woo! Okay, that was kind of creepy. Woo!